Hello everyone. In this session, we'll discuss about sixth program of C Programming Laboratory. Let's begin with the problem definition. Introduce one-dimensional array manipulation and implement binary search. So here, what is an array? Array is a collection of similar data type elements. For example, a list of odd numbers between 0 to 100, which holds all integer values. Then what is one-dimensional array? One-dimensional array or a single-dimensional array holds single subscript. Then what about the binary search? Binary search is a search algorithm that finds the position of a target value within a sorted array. Binary search compares the target value to the middle element of the array. How it is, we'll see with one small example. So in this example, we have 17 elements which are placed in a sorted order, and each element is defined with the index, and index starts with a 0 and ends with a 16. So the 0 index is called as the lowest index, and 16 is called as the highest index. As the algorithm states, every time to search for the key, we have to find the mid value. Here we have taken the key as 7 as a key which we have to search in the list. First we need to find the mid value to search the 7 in the list. To find the mid value, we have to compute the mid value using the formula low plus high divided by 2. So our lowest index is 0, highest index is 16, divided by 2 is 8. At 8th index place we have 14. Now we have to compare 14 and 7. If it is smaller, then we have to search in first half of the list. Otherwise, we have to search in next half of the list. So 7 is less than 14. We are searching in the first half of the list. Now the lowest index is 0. Now highest index need to be reassigned with the value mid minus 1, that is 7. So in between 0 and 7, we have to search our key in the list with the first half of the list. Now 7 is less than 14. Again, we have to compute the mid value with the lowest index and highest index of the first half of the list. That is 0 plus 7 divided by 2. That is 3.5. 3.5 is rounded up to 4. At fourth index place we have 7. So our key is 7, and at fourth index place we have 7. So it is equal. That means key is found in the first half of the list. Then we have to stop here only for the searching the key. This is how we have to search for the key. We'll see first the algorithm. Start with the asking the user to enter the array size and read the array size. Then ask the user to enter the values for the array, that is members of the array. Then read the members of the array using the loop, for loop, and then ask the user to enter the key which they have to search, read the key. After that, assign the lowest index value and highest index value. Lowest index will be 0 and highest index will be n minus 1. And then if lowest index is less than the highest index, then do the next 3 steps, that is 10 to 13. Compute the index mid value, that is using the formula low plus high divided by 2. After computing, if key is equal to num of mid, then key is found and stop searching from this position. Else, compare the key and a mid value. If it is less than mid value array element, then search in the first half of the list. If it is greater, then search for the second half of the list. If key is less than array of mid, then reassign the highest mid value because we have to search in the first half of the list. Else, reassign the lowest index value to mid plus 1, and we add that because we have to search it in the next second half of the list. And then print the key and print the message that found at the mid place. That will be end of the algorithm. Similarly, the same algorithm is represented in the flowchart using the input as array size and array elements and key which we have to search. And low is initialized as 0 and high is initialized as n minus 1. If low is less than or equal to high, then compute the mid value. If a mid value of key is equal to num of mid, then key is found, then come out of the loop. Else key is greater than num of mid, then we have to search the key in the second half of the list. That time we have to reassign the lowest index to mid plus 1. If it is key is less than num of mid, then we have to search in the first half of the list. Then we have to reassign the highest index to mid minus 1. So if once we are coming out of the loop, if low is less than or equal to high, that means record is found. We are displaying the message found record, else we are displaying the message not found record. So that will be end of the flowchart. Let's see with the code. So very first statement is a header file with stdio.h. It's a mandatory header file what we are using, and our execution starts from main function. And initially we are defining the array of size 10 of integer data type, and we have defined with the 5 integer variables. Next we are using the print statement to asking the user to enter the array size, and we are reading the size through scanf function, and again we are asking the user to enter array members one by one through the scanf using the for loop, and then we are asking the user to enter key which they have to search, and we are reading the key through the input device, and initializing the lowest index to 0 and highest index to n minus 1, that is array size minus 1. While low is less than or equal to high, then we are computing the mid value. If key is equal to num of mid, then key is found and come out of the while loop. If not, then key is greater than num of mid, then change the lowest index to mid plus 1. Else change the highest index to mid minus 1. After that, if a low is less than or equal to high, then print key is found at the specified mid position, mid plus 1 position. Else just print key is not found. So this is all about the code. After writing the code in the editor, compile the code for error. So using the command gcc filename.c, file name can be your file name what you have defined. After compilation, run the program using the command ./a.out. Just see how we can execute the program in real environment. So here we have a program for the binary search, and I have given the file name with the P6. So now compile the program using the command gcc space file name dot c. So program is compiled. Now run the command using command a.out. So it's asking the user to enter the array size. I will give array size 6, and it is asking the user to enter array members. Okay, so I will give 4, 5, 7, 8, 9 and 10. So it is asking to enter the key which you have to search. I will give 8 as a key which we have to search in the list. So it is displaying key 8 found at the position 4. We'll see one more example which is not there in the list. Okay, so I'll enter array size as 5 and enter the array numbers one by one. I'll enter 2, 3, 5, 7, 9 and enter the key which you have to search. I'll enter 1 which is not there in the list. Well, let's see what it will display. So it is displaying key not found. So this is how you have to execute the program. So, thank you.